Daubonier's Trades Law. Daubonier's law of trades states when three elements in a trades are listed in the increasing order of their atomic masses, the atomic mass of the middle element is the arithmetic mean of the first and third elements, and then these elements will show the similar properties. Let us take the first group of trade, that is lithium, sodium and potassium. Atomic mass of sodium is the average atomic mass of lithium and potassium. Let's calculate. Atomic mass of lithium is 7 and potassium is 39. Average atomic mass of lithium and potassium is equal to 7 plus 39 divided by 2 is equal to 23. What is 23? 23 is the atomic mass of sodium. Similarly, strontium is approximate average mass of calcium and barium, that is 88.7. Bromine and iodine is approximate average mass of chlorine, that is 79.9. Newland's octaves. The law states that when the elements are arranged in the increasing order of their atomic masses into octaves, then there was similarity of properties in every eighth element. For example, fluorine, which is the eighth element, and the hydrogen, which is the first element, have the similar chemical properties. Sodium is eighth element and lithium is the first element, have similar chemical properties. The defect in this classification was all the known elements discovered later could not be correctly arranged into octaves. Some elements having different properties were placed in the same rows, like cobalt and nickel having different properties are placed along with fluorine, chlorine and bromine. Iron having properties similar to cobalt and nickel are placed in different rows. Mendeleev's periodic law. Mendeleev's periodic law states that the properties of elements are periodic functions of their atomic masses. Mendeleev classified elements in the increasing order of their atomic masses and similarities in their properties. The formula of the oxide and hydrides formed by the elements was also the basis for the classification of the elements. Mendeleev's periodic table has 6 horizontal rows called the periods and 8 vertical rows called the groups. The groups 1 to 7 had 2 subgroups called A subgroup and B subgroup. Group 8 had 3 rows of elements. Elements having similar properties were placed in the same groups. There are some spaces left vacant in the table to accommodate the elements to be discovered in the future. Merits of Mendeleev's periodic table are: he predicted the discovery of new elements and left blanks for them. He corrected the wrong atomic weights of some elements. For example, the inert gas elements discovered later could be placed in a separate group without disturbing the table. Mendeleev boldly predicted the existence of some elements that had not been discovered at that time. Mendeleev named them by prefixing a Sanskrit numeral eka or 1 to the name of the preceding element in the same group. For instance, scandium, gallium and germanium discovered later have properties similar to eka boron, eka aluminium and eka silicon respectively. Some elements are not arranged in the increasing order of their atomic masses. CO is placed before nickel, tellurium is placed before iodine. Position of hydrogen is not clear because it shows properties similar to metals as well as non-metals. The position of isotopes of elements is not clear. Modern periodic law. Modern periodic law states that the properties of elements are periodic functions of their atomic numbers. Look at the modern periodic table. There are 7 horizontal rows called periods and 18 vertical rows of elements called the groups. Select the drop-down menu to know the modern periodic table. Valence electrons and valency. In a period, the number of valence electrons increases from 1 to 8 from left to right, and the number of shells is the same. Look at the lithium. It has 1 valence electron. Beryllium has 2, boron has 3, carbon has 4, nitrogen has 5, oxygen has 6, fluorine has 7, and neon has 8 valence electrons in the same shell. Thus, the valency of the elements increases from 1 to 4 and then decreases from 4 to 0 from the left to right in a period. So, chemical properties of periods vary from left to right. In a group, the number of valence electrons is the same for all the elements, but the number of shells increases from top to bottom. Thus, the valency is the same for all elements of the group. So, chemical properties of similar group are same. Atomic size, radius of the atom. In a period, the atomic size of the elements decreases from left to right because the nuclear charge, that is the number of protons, increases, and so the electrons are pulled closer to the nucleus. In a group, the atomic size of the elements increases from top to bottom because the number of shells increases and the distance between the nucleus and shells also increases. Metallic property, electropositive nature. In a period, the metallic property of the elements decreases from left to the right. For example, third period, sodium, magnesium, aluminium are metals. Silicon is metalloid and phosphorus, sulfur, chlorine, argon are nonmetals. In a group, the metallic property of the elements increases from the top to bottom. For example, in group 14 or 6, carbon is a nonmetal, silicon and germanium are metalloid, while tin and lead are metals. In a period, the non-metallic property of elements increases from left to the right. In a group, the non-metallic properties of the elements decreases from the top to the bottom.